everybody knows air pollution is ruining our health. The automobile continues to be the major villain because no alternatives have been found. Until now.
Now, how much do you cut down the way of pollution, the exhaust?
Well, we are only 1/12 the levels permitted by the 75 heavy-duty standards on carbon monoxide.
Is that right?
Yes, right. What we have here, Senator, surprisingly, is the only operable bus that meets the 1975 California standards. In fact, a fellow walked by the street yesterday and we had the door up and he says, "What's that in there?" And I said, "Well, that's a steam engine." And he says, "A steam engine? Why, they've got one of those down at the Smithsonian."
Man has been experimenting with steam devices for centuries.
In England, the patent was granted by Charles I in 1631 to a young Scotsman named David Ramsay to cover a number of inventions. To raise water from low pits by fire, to make any sort of mill.
Invention number 98 by the Marquis of...
An engine so contrived that working the prima mobile forward or backward, upward
Water
or
being
downward.
evaporated by fire, the vapors require greater space, about 2,000 times.
Therefore,
than
I
that
call this a
occupied by
semi-omnipotent
water.
engine. and
Of
do
the
intend
55
model
patents
thereof
granted
be
for
produced.
inventions during the reign of Elizabeth, 1 in 7 is for the raising of water.
The principle of its employment was not the force of steam under pressure, but the force of atmospheric pressure against the
To raise water
evacuated
by
space.
fire.
To raise water by fire.
In the early years, steam was competitive with the internal combustion engine in the marketplace. The Stanley Beetle steamer in 1906 held the land speed record at 127 miles an hour. Steam development lagged, however, when engineering resources were applied to the internal combustion engine, which, for the time being at least, proved to be simpler, cheaper, and more convenient. Henry Ford captured the market with his Model T, which was so simple it could be mass-produced very cheaply. With all these cars on the road, there has come a change in the land and in our way of life. "75 years after the development of the gasoline engine, the dark side of the internal combustion engine has become apparent everywhere.
The automobile is the major source of what we call the precursors of the photochemical smog problem.
30% of land in central U.S. cities is devoted to the automobile.
The first one on my left is a very clean lung from an individual who didn't smoke and was exposed to very little air pollution. On the other hand, on my right is a lung of a man who was a heavy smoker for many, many years. Also lived in the city where there was a great deal of exposure to common air pollutants.
Air pollution in Manhattan has the same effect on one's lungs as smoking 2 packs of cigarettes a day. The death rate from emphysema is doubling every 4 years.
This tree is affected by smog, and as you can see by comparison, it has only the current year's complement of needles, and last year's needles to be exact. All the other needles that should be on it have since been killed and dropped off.
The automobile kills 60,000 Americans a year.
In the future, which looks very bleak, gases such as carbon monoxide, sulfur dioxide.
That we're on a collision course, in the sense that the human being is being exposed to more and more smog.
About 90% of air pollution in California is caused by motor vehicles. Smog will get worse, especially in view of a future with more cars traveling greater distances. 60 miles, somewhere down there, is Los Angeles and 6 million people. Scenes like this convinced the California Legislature that someone would have to make a fast choice or we would all choke. In the fall of 1968, staff representatives of the Assembly Office of Research contacted the Urban Mass Transportation Administration about demonstrating the feasibility of steam power systems. The project was funded by a $2.3 million federal grant to the Assembly Rules Committee and was the first such grant ever given to any state legislature. Because of the fear that emission control devices might fail, the legislature wanted to explore a total power system which was inherently clean, practical, and if it could justify tighter emission standards in the future. We hope the feasibility of steam power will be demonstrated beyond any doubt in this project.
3 firms were selected to develop 3 separate buses. William M. Brobeck and Associates of Berkeley, California, a company noted for research and development of cyclotron equipment, began designing an engine to power a bus for the Alameda Contra Costa Transit District.
This will solve the pump problem.
Lear Motors Corporation of Reno, Nevada, founded by William P. Lear, developer of the executive jet and many other things, has for a number of years experimented with steam engines and began designing a system to power a bus for the San Francisco Municipal Railway. And Steam Power Systems of San Diego began building an engine for the Southern California Rapid Transit District in Los Angeles.
This is the basic shop area where we fabricate all of the boiler ourselves. Some of the precision machine parts are made on the outside. They're brought in here for various inspection procedures and assembled from there on. This is one of the rooms of our engineering department where basically almost half of the work is done. It's not generally realized that to create machinery like this, you have to go through a process of conception, analysis, design, detailing, and considerable checking. Basically, these people in this room are design engineers, and they are detailing the parts that will be made for the bus program.
The basic principle of all modern steam engines is the same. The steam is recycled instead of exhausted. Water is fed by a pump to the tubes of a steam generator or boiler to be heated to steam, which, controlled by a throttle, drives the expander or engine. Then the steam is exhausted to a condenser, essentially a large radiator, to be cooled back to water. Fuel is burned outside the engine in a continuous process, much like the burning of a gas stove. Because most of the fuel is consumed continuously and completely, almost no residue is emitted into the atmosphere. Two types of expanders are used in the buses. A turbine, shown here, is used by Lear, and a piston or reciprocating type is used by Steam Power Systems and Brobeck.
The low pollution potential of a steam engine is demonstrated by this chart that shows that a normal size family or luxury type car, as we put it here, would produce as much smog with an internal combustion engine as 4 economy size cars, which in turn would produce as much pollution as 19 steam cars. Basically, we see it as a program to develop a low polluting mass transportation so that we can do some of this replacement of personal vehicles to produce much less pollution than all the cars that are being used for personal transportation today. We are now starting assembly of our bus boiler in its final configuration. It will be installed in the lab for testing next month. Here's one of the outer skins that's going to make up this boiler in various stages of fabrication. If we walk down to the end here, we can see the steam generator being assembled in the weld shop. Basically, air comes into this unit, fuel is combusted down in this end, it travels down through the other end and is exhausted out. Water comes into the tube and steam leaves to the expander.
Old-fashioned boilers were eliminated. The new steam generators, with about 1/4 mile of small diameter tubing, are inherently free from the danger of explosion. Each component was bench tested individually over a period of many months before assembly into the power system.
The purpose of this operation here is to check the performance of the boiler, which means the amount of fuel it uses and the amount of water it boils and how efficient it is. This testing is going to go on here for about 2 more months. Then we expect to bring the engine into this room with a dynamometer and have the whole power system running at the same time.
Many questions had to be answered before the whole system was installed in the buses.
And we're preparing right now to test some condenser. We have to fire the boiler to do that. The man just turned on the switch here, which would normally be the ignition key for the automobile engine, or the bus engine as it may be, and he's now preparing to put live steam down to the condenser. The steam generator is operating on the other side of this glass window. You can see now the pressure gauges and temperature gauges starting to come up on the steam generator.
It's air-bound on one cylinder.
started up fine. We had our usual small problems of getting it going, but then it took off fine.
And what was the top speed you attained? If that would have been in the car, how fast would we have gone?
Well, you had 45,000. 48,000 for a while, so we were a little bit over 100 miles an hour. It's easily as good as it was Wednesday or better.
Well, and you think the whole control problem is solved?
The car is getting almost modified to the point of dropping in the condensers. The regenerator materials are on order. The turbine gearboxes are made up. The turbines are ready to be made up.
Because external combustion engines of the type required were not available on the market, the three vendors had to design, develop, and build the experimental power plants by hand. A lightweight and efficient steam system requires the use of high temperatures and pressures. Extremely close tolerances, sometimes as small as 10,000ths of an inch, are often needed. Mr. Brobeck's experience with the Doble Corporation in the 30s led to the design of his power plant.
The way we're working on the bus, the design of the power plant we're using is a subsequent development of these old Doble power systems. But they were very advanced for their time, and they're even very advanced for today. I worked on these power plants, not on this particular car, but on power plants like this when I first got out of college, back in 1930 through 1937. And at that time, these cars were finished, but the work I did was on similar power plants for railroad cars, trucks, and buses. And so I learned a lot that's applicable to this bus program.
The Bessler Corporation, which took over the Doble Company, supplied a steam power plant for a two-car commuter train. Their belief that steam was a superior source of lightweight power was dramatically demonstrated in 1933, when William Bessler flew a steam-powered airplane at the Oakland Airport.
We studied everything that Abner Doble did and why he did it. And from that was our starting point. Now remember that at the present time, the automotive industry has spent about between $50 and $70 billion on the development of the internal combustion engine over a period of 70 years. Obviously, it's going to be the trick of the year or the trick of the century to come up with a substitute for what they have been able to accomplish in those years. It took us 2 years to find out that all of the ideas we had for small reciprocating engines just weren't worth fooling with, and that we had to go to a turbine. So we came up with a wheel, and this wheel has 100 blades on it, and we can put a nozzle on one side of it, and the steam comes out and pushes the wheel. And as far as I can see, we have licked the major problems. The problems we have from here on out are the kind of problems you have when you assemble anything together, such as belts and gears and pulleys and so forth. But we think that we can deliver a bus sometime within the next 3 or 4 months that will be outstanding in its performance, in its appearance, and its economy. And of course, my objective is to ultimately be able to outperform the diesel engine as far as economy is concerned. At the present time, we don't expect that we can do it. But after all, right now the important thing is, what will the pollution output be?
After the steam systems were installed in the buses, extensive road tests were conducted to further evaluate safety, reliability, and performance.
lots of sandbags.
Tests of the Brobeck bus were finished first, and it was taken to Washington in November of 1971.
Good morning and welcome aboard the first modern steam bus. The purpose of this project is to demonstrate the potential of an external combustion engine, a steam engine, as a low-emitting power plant, pointing the way to low-polluting mass transportation of the future. This is one of 3 buses being developed for this project. This particular bus a year ago was a diesel bus. It's been converted to steam power by William Brobeck and Associates of Berkeley. With the different designs being presented in this early experimental program, we hope to learn much about the route to take to that engine of the future.
What's the top speed? No, it's inside of the captain on 58 miles an hour. They're voting, and I want to get back there for the next one. Steam will get you there. Steam will get you there. You know, if it works, if it gets me there in time for the vote, I'm for it. Okay. Thank you.
This is the first that I have seen. It looks good. It rides comfortably, and it has a good deal more testing to be done. But I look forward to the possibility that we will have something other than an internal combustion engine. I would expect that within the next year or two, you'll start to see one or more of these buses get into production.
In April of 1972, all 3 buses were completed. They were taken to Sacramento for testing and another public demonstration. The California Air Resources Board performed comprehensive exhaust emissions tests. A standard diesel bus and all 3 steam buses were tested in a common manner. The procedure was to load the vehicle as though it were on the street or highway with a chassis dynamometer, the set of rollers that the rear axle operates on. Then the exhaust was sampled by means of a probe inserted in the exhaust stack of the bus, leading through a rubber hose to a van where the gas was separated into its components and recorded with high accuracy, a few parts per million. The raw data was then analyzed by computer and summarized on a comparative basis. Results of these tests show that diesel buses failed to meet 1975 state emission standards, while steam buses bettered these requirements by more than 2 to 1. The steam bus reduced carbon monoxide by about 50% and lowered hydrocarbon and oxides of nitrogen by 80% when compared to the diesel. The diesel bus does not nearly meet the 1975 state standards, while the steam bus easily does. The buses were designed to show the feasibility of the steam engine as a low-polluting means of transportation. 2 of these prototype buses were also quieter than the diesel buses in tests performed by the California Highway Patrol.
79.5.
The buses were then demonstrated to the public and California legislators in front of the state capitol building.
It can work. There is absolutely no question that the amount of pollution emitted from these vehicles is tremendously lower than the vehicles being used today. The fact is that I believe each one of these vehicles is capable of more than meeting the 1975 pollution standard. They're also as efficient, as powerful, and I think in the long run will be as economical as vehicles being used today. I'm very disappointed at this point that Detroit has seen fit to try to poo-poo the possibilities of a steam engine. We know there's a tremendous number of dollars involved in their reconversion to a steam engine from the internal combustion engines being used now. But it's something that's got to be done. All we want to do is have them recognize it, assist us, so that places like California, like Los Angeles, don't have to be the smog belts they are now. We thought that we'd give all of you an opportunity to see why we ought to be thinking in this direction in the years to come.
Thank you. Welcome aboard, Steambus man. Welcome aboard our steam bus.
Oh, thank you. Well, is that what we're riding on?
The Brobeck bus went into public service in Alameda County on May 25, 1972, with the Lear Turbine bus slated to begin its revenue runs in July, and the SPS bus scheduled for public service in Los Angeles in August. The public service demonstration was possible only with the cooperation of the transit systems.
We in the transit industry are convinced that we have to join the American public in trying to clean up our environment. One of the issues that we're faced with is trying to quiet the noise of our operation. And we're also concerned in trying to eliminate, so far as we possibly can, the smog-producing activities of our equipment. The STEAM project that we're engaged in at the present time, we feel is making important strides towards this accomplishment.
Even though the buses have operated in public service, we are a long way from seeing the internal combustion engine replaced. The project was a success. We know that steam means cleaner and quieter transportation. But now if this knowledge is to be used, we must support the long and even more costly effort of transforming these working prototypes into production models. In the same way that the internal combustion engine was the answer in the early days of the automobile, steam may be the answer in the days to come.
Some more to Steambus, sir. Oh, you're getting a Steambus. That's what you're riding on right now. That's what you're riding on right now. Right now, a Steambus. Yes, sir. Good Steambus. All right, better than gas.